so this is law of multiple proportions, which in your guided notes you did have practice problems with this. But we're going to go through this one problem together just to make sure that you know how to do it. Okay. Law of multiple proportions is mainly for covalent compounds, because covalent compounds can combine in multiple proportions with each other. Like nonmetal atoms can combine in multiple proportions, which is why you can have, say, carbon monoxide, CO, and carbon dioxide, CO2. Same combination of, or same two elements in these two different compounds, but different proportions. Ionic compounds typically follow the law of definite proportions, where they only form in one type of proportion, okay? When we have something with multiple proportions like this, so we have this. Two elements, R and Q, combine to form two binary compounds. What does binary mean? Two atoms in there, okay? In the first compound, we have 14 grams of R combining with 3 grams of Q. And in the second compound, we have 7 grams of R combining with 4.5 grams of Q. We're going to show that these data are in accord with the law of multiple proportions. If the formula of the second compound is RQ, what is the formula of the first? So let's just look at the data for the two compounds. Let's look at the ratio of R to Q for each compound. What's one way we can write a ratio? A fraction. So let's write it as a fraction. So for compound 1, let me make sure I'm on the pen. For compound 1, let's write a fraction of the mass of R over the mass of, I did that last time too, grams Q. All right, so go ahead and calculate that. Go ahead and reduce that fraction down. Hopefully some of you have a calculator. So what is 14 divided by 3? 4.666666 repeating, right? So I'm just going to say 4.67. So that means for every gram of Q, I have 4.67 grams of R, right? I'm just reducing that down to compare it as 1 gram of a substance. Now let's do the same thing for compound 2. Using the second set of data, one comment I do want to make is, with a lot of math problems in chemistry, there are multiple approaches to solving it. You might have been able to get to the correct formula of the first compound containing R and Q in a different way, but again, what do I care about? Showing your work. That you show your work, and obviously that you get the right answer, because if you're doing it a different method and you're not getting the same answer, you're doing something wrong, okay? But this is how my brain works, so I'm showing you how I'm doing it, but if you find a different way that works for you, do it that way, okay? So now, what is 7 divided by 4.5? 1.56 grams of R for every 1 gram of Q. All right, so now we know for each compound how many grams of R we need for grams of Q. Now let's compare the R's for each compound. Let's find the ratio of R in compound 1 to R in compound 2. Okay. So I'm going to take the 4.67 grams of R in 1 divided by the 1.56 grams of R in compound 2. This will give me my ratio of R that combines with 1 gram of Q. And what is that?
1.56.
So essentially 3, right? So this is the ratio of R that combines with 1 gram of Q. Right. So if we know that compound 2 is RQ, right? We know it's that. Well, in compound 1, there's 3 times as many R as there is in compound 2. So therefore, what is the formula for compound 1? R3Q. Okay? Your book and therefore your guided notes have more problems with this. If you skipped over those, or if you really weren't sure what to do there, go back and retry them, okay? And then your homework has a couple problems with law of multiple proportions as well. Right? It's not a huge topic with AP Chem, by no means. It's just new. You might not have learned this in first year Chem. I don't think we teach it here at this school at all. Okay. All right. Next little bit from this chapter is protons, neutrons, and electrons. This is, should be pretty much a review. I'm just going to do a couple of these to make sure we're all on the same page. Let's do B and D. All right. So we have the standard nuclear notation written out for these different elements. So looking at B, what element is that? Magnesium. Which of these numbers will tell me the number of protons? The bottom number, because that is the atomic number. An atomic number is the number of protons. So how many protons does magnesium have? 12. How many electrons does this magnesium atom have? 12 as well, because it is neutral. There's no charge written here, so therefore it's neutral. If there was a charge, then we'd have to accommodate for that. And then how do I find the number of neutrons? Yes, subtract the top. Do the top number minus the bottom number, because the top number is the mass number, which is the protons plus the neutrons. So for this atom of magnesium, how many neutrons does it have? 12 as well. 12, 12, 12. That should be easy. Let's look at D. What's weird about D? Or new, different? It has a charge. So what number is that going to affect? The electrons. Good. How many protons? Actually, what element is this? Silver. How many protons? 47. How many electrons? 46, because a positive charge means it lost an electron. It has one more proton than it does electrons, so 46. And neutrons, yep, we're going to take 107 minus 47 and get 60. Good. That should be very straightforward. All right, and then the rest of the chapter 2 stuff that we have practice problems with are all naming. No, we are not going to spend this entire time going through every single one of these, because that's way too much. We'll do a select few from each section, and the other ones you can do as extra practice. We can go over more of them next class after the lab, but I'm just going to hit a few of them right now, okay? So for example, the first section are binary compounds. You already told me this, but just to remind me, what does binary mean? Two. So all of these are all binary compounds, meaning that they only have 2 atoms. It goes all the way down to 31, okay? All right, so let's just do a couple of these. On this first page, we have all ionic compounds. So let's look at we'll start with this one, K2S. What two elements do I have there? Potassium and sulfur. How do I name potassium? Potassium. It's a metal, right? You don't change its name. Does potassium need a Roman numeral? No. If it's group 1 or 2 metals, it never gets a Roman numeral. I'll talk about the transition metals in a little bit. But group 1 and 2 metals never get a Roman numeral. And then, how do I name the sulfur part? Sulfide. Remember this stuff from last year or 2 years ago, whenever you took first year chem? All right, let's look at, we'll do this one. Cu3N2. What two elements do I have there? Copper and nitrogen. Now, copper is one of our transition metals. Most of our transition metals need a Roman numeral, and the Roman numeral indicates what? The charge. I heard somebody say it. It indicates the charge of that metal, okay? The exceptions to transition metals that don't need a Roman numeral are zinc, cadmium, and silver. Zinc and cadmium are always +2, and silver is always +1. And then within the P block, the few P block metals we have, the two that will always get a Roman numeral are tin and lead. The other ones, either they don't get a Roman numeral or we just don't use them. Like bismuth, we don't really deal with that one, okay? So, copper is going to need a Roman numeral. What Roman numeral is it going to get? 2, because that's its charge. Remember, this was Cu plus 2 and N minus 3. Crisscross down to get those subscripts. So copper 2, and then how do I name the nitrogen? Nitride. My pen is skipping. Okay. Let's look at, oh, hey, look, I said we don't use bismuth that much, and look at number 23. I lied to you, sorry. Number 5, calcium sulfide. Calcium sulfide. Calcium has what symbol? Ca, with what charge? +2. It's a group 2 metal, so it's always +2. What's sulfide? S minus 2. So when you crisscross down, what do you get? CaS. What happened to the 2's? They canceled out. Remember, if charges can reduce down, do that. When we talk about ternary, with the ones with polyatomic ions, you won't ever change the polyatomic ions formula. Okay? All right, let's do that bismuth one, since I lied to you about that one. All right, so bismuth, what symbol does bismuth have? Bi. What charge is this bismuth going to have? +5. And sulfide is S minus 2, just like before. So what's the formula? Bi2S5. Cool? Straightforward. Lovely. All right, the next section, well, actually it's all one section for you guys, but my next page are all covalent compounds. What do we use when we name covalents? Prefixes. Prefixes. The second element, the second nonmetal in your covalent compound, its ending gets changed to IDE, and you always give it a prefix. The first element's name doesn't change. You only give it a prefix if there's more than one. Remember, you never put mono on the first element. Okay? So for example, in number 9, how would we name that? Nitrogen monoxide. And how would we name number 26? Exactly, tetraphosphorus decoxide. Notice how these subscripts, it looks like you could reduce them down, but you never reduce covalence because that's what the molecular formula is. So tetraphosphorus decoxide. What about 15? What would the formula of that be? What's the symbol for xenon? Xe. What subscript is it going to get? A 1, so we don't write it. Yep. And then tetrafluoride is what? F4. Please be aware that Fl is not the symbol for fluorine. Fl is a newer element that has been named called fluorovium. Therefore, it's not on that periodic table. Therefore, if you put Fl, you're actually giving it, you're saying it's a different element. It used to be, before they actually came up with that name, it used to be, I was like, hey, that's just the wrong symbol. Now it's actually a completely different element. Okay? So covalent's pretty straightforward. All right, ternary. You know what? I'm actually going to pause here because we don't have a lot of time left. And like I said, we are going to have some time after our lab next class. Okay, so let me finish recording. I don't know how to stop.
Is the mic off?
No.
Well, we're recording on.
I can't figure out how to stop recording. Things changed, and now I can't stop my recording.